In this video, we're gonna DevTool the Apple website. This is part of a series that I started where I pick up popular websites and go through the DevTools in Chrome and look at the communication protocols, what kind of protocols they are, what kind of servers they use, what kind of lessons we can pick up as backend engineers and front-end engineers. So if you're interested in this stuff, stay tuned and check out the playlist to see all these, the entire series. Let's just jump into it. So I would start by going to the desktop version of apple.com. Thank you everybody for who told me there's this toggle device toolbar that I didn't know existed, and you guys made fun of me for that. So thank you so much. And what I'm gonna do is first I'm gonna go to apple.com and hit enter, and let's just wait for all the flow to continue. And look at all this. This one is very interesting. The last one. We're going to come to it. Let's stop the recording of the network calls and let's take a look. So here's what the first thing we notice is the first call to apple.com, which is a GET request, was using the HTTP 1.1 protocol that tells me it is an insecure communication, right? Not necessarily, but most of the time. Why? Because when we click on that, look at this. They connected to the port 80 on this IP address. Why? That's because Chrome could not figure out whether apple.com as a domain does support HTTPS or not. So it says, hey, I don't know. I'm going to assume it only supports HTTP. So that's why it does the HTTP first. That is a big flaw in the most of the websites. I talked about it right here. This is essentially the difference between www and .apple.com or google.com versus just google.com. Right? There's something called the HSTS list, which I talked about, but this essentially gives hint to the browser that says, hey, this site actually supports secure communication. So just go ahead and connect to 443 and establish TLS, right? But the knowledge for when a subdomain is missing is not there. So I talked about it, submitted a bug about it, but they say, hey, it's the server's problem. The server should tell us that apple.com is on the HTTPS list so we can communicate with securely in the future. But alas. All right, so the next thing after we communicate, after we took the hit to establish a TCP connection, right? Because that's what we did. We established a DNS lookup. Took me 11 milliseconds, not that much. Initial connection, not that much. But then we just turned around and closed that connection anyway. Why? Because this is a redirect call. Where are we going? We're going to https apple.com. Please close this connection immediately and go to https www.apple.com instead. So that's what the browser did. The browser initiated a new negotiation with www.apple.com instead, which might have a different IP address, which it did. It doesn't have a different IP address and connect to a 443. And during the TLS handshake, it actually find out that it supports HTTP2. That's what it did. So we're looking at DNS, we're looking at 46 millisecond connection, SSL 34, which is pretty good. 34 tells me that this is definitely a TLS 1.3. That's right. A single beautiful round trip. All right, so the next call was just to get the actual content of apple.com, which happened to be text HTML, right? That's the response. Look at it, all the HTML file. It looks ugly as F. It looks ugly as F because there are no CSS files, right? But then the next calls are all calls to actually download the content, which I'm not really interested in. Look at the connection ID. The connection ID are all the same, right? But I'm starting gonna pay attention to the things that talk the most, right? From now on. And this is the thing. It almost takes a second. What is 874 millisecond? What the heck is this? main.build.css. Oh yeah, that what makes Apple pretty, right? And it took, look at this. The time for the first byte took 144 millisecond, which is not fast by any mean. Just to get the first byte, that took a long time for some reason. And then to actually download the content, it took 700 millisecond. How big is this thing? Do they even tell us? They do not. So we cheat. I'm gonna copy the whole thing, paste. How big is this thing? Boom. It's 866 kilobyte, almost a meg. Yikesy. That's a big CSS. That I guess that's what make Apple pretty, huh? All right. So that's it. I don't know if they can do anything about it. It's just a huge CSS file. That's one of the, I guess, limitation of CSS, right? You can, I guess, compress it and do all this fancy stuff, but still. And yeah, but the good thing about this is just is a single stream, right? That's the beauty of HTTP2. We can multiplex all this stuff into multiple streams. We cannot do that in HTTP 1.1. We have to open multiple TCP connections. So still, one stream suffered, but the rest are just gone. There is another one that took 100 millisecond. That's just a JavaScript file. I'm assuming it's also a large file. Some of these calls do not have content length for some reason. I really don't know why. Look at this. Look at this bugs. That's a typo. Apache, what are you doing? I'm saying Apache because that's the server, basically, that Apple's using. They're using Apache. You can tell so much stuff. That's fancy. I love that typo. Let's continue. All of this 50, 40, that's kind of acceptable. They don't know the SVG's file. They don't know all that stuff. Here's the one that 180 that the HLS. Ooh, HLS. I heard this before. What is HLS? Gotta be some fancy JavaScript. Again, they're using the experimental JavaScript header, X JavaScript. I have no idea why. There is an application that JavaScript header that they should be using. Them using this is just weird. Let's continue. And we can see that 2 brand new TCP connections have been opened, TLS as well, right? 2 different domains. One is apple.com, securemetric.apple.com, and securemvt.apple.com.cn. Right, and those two have the same connection ID because they're the same domain. But why are we doing that? That's probably just some metrics, right? So it's not so bad. They try to make everything in the same domain because they're using HTTP2. That's kind of great. And the final thing that we can learn from actually is this. Look at this. The large.mp4 file. What is this? That's the fancy 550 AirPod Max. That's the video. And it's there. We're going to learn this lesson. We learned it from YouTube. This is called 2SX, which is the partial content. The partial content, that tells me that the video is being downloaded partially. It's streamed, right? Not all at once. Why? Well, that's why. Because it takes 2 seconds to download that. Imagine blocking the user to download this thing, right? So instead, you're not gonna be blocked, but you're not gonna see anything until that 2 seconds is elapsed, which is a very bad user experience. So using 2SX as a partial content is a great idea, so that you can immediately stream the partial content, so the user can actually see stuff. And as the video continue downloading, the user already starts seeing this beautiful mic that I don't know who's gonna buy. All right. So all right. This is it. That's the basically Apple website. How about we go to the mobile version and see if there's anything different? All right, we're switching to mobile. iPhone 10. Clear. Going to apple.com. This time I'm going to go to www.apple.com so you guys can see the reference. But look at this. This is way faster. Why? That's because immediately the first connection is secure, so we don't have the problem with the first connection being insecure, so that someone can in the middle intercept and give us a phishing website, right? Because this can happen, and then nobody's talking about it. I'm just fascinated by why is no security researcher talking about this huge flaw in the system, right? The first call is unsecure, and when you go to an unsecure site, I can, if I am in a hotspot, or even if I'm a shady ISP, I can serve you some other content that looks exactly like Apple, or some other content that looks exactly like Google. Nobody's talking about this shit. I don't know why. So here's the same thing. Nothing fancy here. It's the exact same thing. We'll look in the whole thing. Yeah, we're just downloading everything in HTTP2. And here's one difference. They're downloading a small version of the MP4. That's good. That's one difference that you need to know, right? Probably the content is smaller. Where's this huge ass file, that main.css? Is it still? Oh, the huge file is all of a sudden takes 200 milliseconds instead. Is that simple? Smaller? Let's take a look. Yeah, look at this. It actually small. It's only 300 kilobyte for the mobile version. So yeah, that definitely, guys, right? If you, the knowledge that you're coming from mobile can give you so much information to kind of compress, can provide different content to mobile users than desktop users, right? Because desktop user can afford to wait a second like we saw, right? But mobile users, no, they have ADD. They cannot possibly. All right, guys, that was a quick video talking about that. What do you want me to dev tool next? Let me know in the comment section below. I'm gonna see you in the next one. You guys stay awesome. Goodbye.